Hi all, this is Lakshmi, working as Assistant Professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the topic which we are going to discuss is the measurement of temperature using thermistor. So we know that thermistor is a temperature dependent resistor. So we can call it as a resistor which is dependent on temperature. So now let us discuss how the temperature is measured with the help of this thermistor. So as I told, these are resistors whose the resistance will vary with the temperature. So the characteristics of thermistors are like we can tell that it directly depends on the resistance. So resistance change and there exists a non-linear relationship. If there is a decrease in temperature, there would be an increase in resistance. So it is having a non-linear relationship and it is having a negative temperature coefficient. We call it as NTC. These are all the characteristics of a thermistor. So how we measure the temperature with the help of this thermistor? So there are three ways by how we can measure the temperature by using this particular thermistor. So we could see that one is a very simple circuit uh, where we use a thermistor and a battery and an ammeter to measure the temperature. So this is a simple circuit. So when there is any change in the temperature, the resistance of the thermistor changes. So that is indirectly calibrated in the ammeter. So where this ammeter gives the indirect measurement of the temperature. So this is a simple circuit through which we can measure a temperature with the help of thermistor. And there is another one which is called Wheatstone network. So we can also use Wheatstone bridge type of network to measure the temperature where we use the thermistor here in this part, which is calculated, which is used to calculate the temperature of the circuit. And also we can use the voltage divider to measure the temperature. So voltage divider in the sense we can go with the voltage division circuit where a voltage gets divided with the series resistance. So where the thermistor is used in order to measure the temperature. So there is a relationship between the resistance and the temperature. So normally that is given by an exponential relation, that is RT is equal to R naught e power beta 1 by T minus 1 by T naught, where T is the RT is the absolute temperature measured in Kelvin. R naught is the resistance at the reference temperature T naught. So that is usually 25 degrees Celsius or 298 Kelvin, and beta is the material constant in Kelvin that is provided by the manufacturer. So in order to, so we have to measure this temperature with the help of the Steinhardt equation. So this thermistor would give us the indirect calibration in terms of the current, that is an ammeter. So that analog value initially has to be converted into digital value with the help of ADC, and then it would be given to the controller or processor to process it and convert it to the real-time temperature values and give it in a display. In order to do that, we have to make use of this Steinhardt equation. So this equation is 1 by T, which is equal to A plus B ln of RT plus C to ln of RT the whole cube. So T is in Kelvin and A, B and C are calibration constants provided by the thermistor manufacturer. So there are two types of thermistors. One is NTC and another one is PTC. So NTC is negative temperature coefficient thermistor and PTC is positive temperature coefficient thermistor. So NTC means so decreasing the resistance with temperature, whereas positive means it is increasing resistance with temperature. So if temperature increases, the resistance also increases in PTC, and if temperature decreases, the resistance increases in NTC thermistors. So advantages and disadvantages of the thermistors are it has high sensitivity, fast response, and it is cost effective, whereas it is having non-linear relationship and limited range of values can alone be measured with help of thermistors, and self-heating occurs which might lead to thermal runaway and fragile. And the signal conditioning is occurring. How it occurs is the linearization, which improves the accuracy by addressing this nonlinear resistance temperature relationship, and the cold junction compensation that would account for the ambient temperature variation, and amplification that is boosting the signal strength, output signal, whereas by enhancing the SNR, that is signal to noise ratio, and by using filtering techniques like the removing noise and interference for clearer measurement. So all these factors would contribute to the efficient use of thermistor, that is linearization, amplification, filtering, and cold junction compensation. So the practical considerations, like as we have discussed, we can minimize the self-heating, we can calibrate the circuit, proper mounting of the setup, and appropriate wiring and the environmental protection could all help us for the proper efficient use of this thermistor. So today's assessment is thermistor typically have, as we discussed, it is having negative temperature coefficient. And the thermistor sensitivity to temperature changes, it is high. And how does a thermistor's resistance change with temperature in NTC? So it decreases exponentially with temperature. Thank you.